The list of the chemical elements in the periodic table is arranged into 18 groups, which are the columns going down, and 7 periods, which are the rows going across, in a way that places elements with similar chemical properties in the same column of the table. The groups can be called 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, or can be called 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. Transition metals are called the B groups, but we won't talk about it today. The group number gives the number of outer shell electrons around an atom. The period number gives the number of energy shells around an atom. To confirm this, we have to choose an element from the periodic table and see its position. Suppose we choose calcium. Calcium has 2 electrons in their outer energy shell, so it is in the group 2A. Also, calcium has 4 energy shells, so it is in the 4th period. Sodium has 1 electron in its outer energy shell, so it is in the group 1A, and it has 3 energy shells, so it is in the 3rd period. Bismuth has 5 electrons in its outer energy shell, so bismuth is in group 5A. Also, bismuth has 6 energy shells, so it is in the period number 6. Tin has 4 electrons in its outer energy shell, so it is in the group number 4A. Also, tin is in the period number 5 because it has 5 energy shells. Elements can be divided into 3 large categories. Each category have their behavior. The elements in the left and central regions of the periodic table, except hydrogen, are metals. Metals have characteristic physical properties such as efficient conduction of heat and electricity, malleability, which means that they can be harmed into thin sheets, ductility, which means that they can be pulled into wires. Also, metals are often have a lustrous appearance. Also, metals have chemical properties such as they tend to lose electrons to form positive ions. They bond to nonmetals by forming ionic bonds. The elements in the right regions of the periodic table are nonmetals. Nonmetals lack the physical properties that characterize the metal. Nonmetals have chemical properties such as they tend to gain electrons in reactions with metals to form negative ions. Nonmetals often bond to each other by forming covalent bonds. Many of the elements that lie along the line that separates metals from nonmetals have properties that fall between those of metals and those of nonmetals. These elements are often referred to as metalloids. Also, elements can be divided into many large categories. Each category have their behavior. For example, these elements are called alkali metals because they react violently with water to form alkaline solutions that are strongly basic metal hydroxides such as sodium hydroxide and potassium hydroxide. They can catch fire when exposed to the air, so they are stored in oil to prevent explosions. These elements are called alkali earth metals because they are soft like earth. They react with water to form alkali solutions that are less basic metal hydroxide than alkali metals such as magnesium hydroxide and calcium hydroxide. These elements are called transition elements because they exhibit transitional and intermediate behavior between the right and the left elements in terms of their physical and chemical properties. These elements are called post-transition metals. The term post-transition metals refers to those elements that are metal following the transition metal. Most of them are soft or brittle with poor mechanical properties and have melting point lower than the transition metal. These elements are called halogens. The term halogens means salt former because halogens form stable and solid compounds known as salt. The most familiar is sodium chloride, that known as common salt. These elements are called mobile gases or inert gases because they are inert because they have completely filled outer electron shell, which means that they don't want to lose or gain electrons at all. They don't want to form bond. They don't undergo chemical reactions. These elements, which are displayed in a separate block of their own, located below the rest of the periodic table, are called lanthanide and actinide. This row is called lanthanide. It belongs to the row number 6. And this row is called actinide. It belongs to the row number 7. The elements in this row are called lanthanides because their properties are extremely similar to the properties of lanthanum. These elements in this row are called actinides because their properties are extremely similar to the properties of actinium. As we say before, these elements are metalloids and these elements are non-metals. The lanthanide and actinide series are more correctly positioned between group 2 and transition series. However, the table must be more compact because it would be impractical to actually show all of those elements in the same place. Therefore, the lanthanides and actinides are split out of the main body of the periodic table into their own rows. Question number 1. Correctly label the different parts of the periodic table using the words in the word bank. The first group is alkali metals. The second group is alkaline earth metals. Some people say that this group is alkaline earth metals and some people say that this group is alkali earth metal. Group number 3 known as metals. Group number 4 known as transition metals. Group number 5 known as lanthanide. Group number 6 known as actinide. Group number 7 known as noble gases. Group number 8 known as halogens. Group number 9 known as nonmetals. Group number 10 known as metalloids. Question number 2. The diagrams below represent various atoms in which only the valence electrons are shown. Use the diagrams to provide the missing information. The first atom has one valence electron, so it is in the group 1a, and it has two energy shells, so it is in the period number 2. This element known as lithium, and it is metal. The second atom has two valence electrons, so it is in the group number 2a, and it has two shells, so it is in the period number 2. This element that is in the period number 2 and group number 2 is known as beryllium, and it is a metal. The atom number 3 has 3 valence electrons, so it is in the group number 3a, and it has two shells, so it is in the period number 2. This element is known as boron, and it is in the metalloid area. The atom number 4 has 4 valence electrons, so it is in the group 4a. And it has two shells, so it is in the period number 2. This atom is known as carbon. It exists in the non-metal area. The atom number 5 has 5 valence electrons, so it is in the group 5a. And it has two shells, so it is in the period number 2. This element is known as nitrogen, and it exists in the non-metal area. The atom number 6 has 6 valence electrons, so it is in the group number 6. And it has two shells, so it is in the period number 2. This atom is known as oxygen, and it exists in the non-metal area. The atom number 7 has 7 valence electrons, so it is in the group number 7a, so it is in the period number 2. This atom is known as fluorine, and it exists in the non-metal area. The atom number 8 has 8 valence electrons, so it is in the group number 8. And it has two shells, so it is in the period number 2. This atom is known as neon, and it exists in the noble gas area. Question number 3. Fill in each circle with one of the following: new element, ion, isotope, molecule. If we add or subtract an electron from an atom, we will find an ion. If we add or subtract a neutron from an atom, we will find an isotope. If we add another atom to an atom, we will find a molecule. If we add or subtract a proton from an atom, we will find a new element.